Ladybugs are typically seen as colorful, charming, and overall aesthetically pleasing creatures, but from the perspective of a pest, they can also be deadly. Pests are a persistent problem for gardens. One of the most common garden pests are aphids. These tiny insects can cause damage to plant growth by tearing up plant tissues and sucking in sap from the leaves, stems, roots, or twigs. This makes them ever present on all parts of a plant as they draw out their nutrients and often leave them with distorted or yellowing leaves. And with more than 800 species in just Canada alone, aphids certainly aren't short in abundance. Chemical pesticides are often used to fight pests such as aphids, but these have many drawbacks. They can contaminate the air, water, and soil, and cause disruptions in the natural balance of a garden's ecosystem by harming soil microbes and other non-target species. Fortunately, alternative solutions are available, such as ladybugs. And this leads to the key question behind this project, which is, what role do ladybugs play in controlling pest populations in gardens? There are over 450 species of ladybugs in North America, almost all of which are predatory, making them prolific hunters. And what's their favorite meal? That's right, aphids. They're able to use their antennae to detect their prey through the sense of smell. Since aphids move very slowly, once a ladybug is able to grab and hold them in place using its mandibles, it can easily chew through the soft bodies of aphids. This efficient hunting style allows ladybugs to eat through all sorts of pests, as they can feast on over 50 species of aphids, and a single adult ladybug is capable of consuming as many as 50 aphids in a day, and throughout its lifetime it can eat over 5,000 aphids. This relationship between ladybugs and aphids is similar to other common predator-prey dynamics. In this interaction, the ladybugs are able to regulate aphid populations and prevent them from decimating the plant populations. This system could be classified as a trophic cascade, which occurs when a carnivore has an indirect positive effect on a primary producer by eating up the herbivores which feast on the producer. In this case, the carnivorous ladybug indirectly has a positive effect on the plant by consuming the aphids. With fewer aphids to drain their nutrients, plants can thrive and grow stronger and produce more flowers and fruits. This, in turn, also gives more support to pollinators like bees and butterflies. This ripple effect highlights the interconnectedness of species and the crucial role that predators like ladybugs play in maintaining balance within an ecosystem. Now, you may ask yourself, what might happen if the ladybugs simply decide to fly away from the garden once the aphid populations are reduced? Would the population of the aphids not recover after a while? Well, in this situation, it's likely the ladybugs may have laid eggs during the time when there were larger pest populations, since an adult ladybug needs to eat around 300 medium-sized aphids before laying eggs, and once those eggs hatch, the larvae that come out can eat enough to maintain control of the aphid population. However, ladybugs don't always need to physically consume aphids to make an impact, as their mere presence is capable of altering pest behavior. When ladybugs walk across plant leaves, they leave behind a trail of chemicals called semiochemicals. These chemical footprints are a form of communication that aphids are able to detect through the odor that's left behind. It acts as a warning for the potential danger of ladybugs and allows the aphids to assess the risk of predation. Therefore, these walk tracks can lead to aphids deciding to not settle on a plant, even if there is an absence of ladybugs. In fact, studies have shown that this effect can be achieved even with a smaller number of ladybugs. As seen in this graph, there was a significant difference in the aphid settling on the plants that had no previous contact with ladybugs in comparison to the ones that had a prior presence of ladybugs for a 24-hour period. But among these groups, the settlement of aphids is relatively similar regardless of the quantity of ladybugs, indicating that even a small amount of presence can result in significant deterrence. Since aphid populations rise extremely fast because of their high reproduction rate, deterring even some of them from making contact with a plant to begin with can be a big deal when trying to suppress their population size. These predatory odor cues can also have an impact on the behavior of aphids that do stay on the plant. Other studies have looked into this phenomenon and found there is a difference in aphid feeding when predaceous odor cues are present. As seen in this graph, the time that aphids take to start sustained phloem ingestion after making contact with a plant is significantly longer in the presence of predatory odor cues in comparison to the control where they are absent. As a side note, phloem ingestion just refers to the aphids consuming sap from the phloem, which is a tissue in the plant. The duration of this feeding is also shortened significantly in the presence of predatory odor cues, as seen in the second graph. So, in essence, these predatory odor cues result in a delay to the beginning of the aphids feeding and shorten their feeding time overall. These types of interactions can be referred to as a trait-mediated indirect interaction, where one species alters the behavior of a second species, which then results in consequences for a third species. In this case, the walking tracks of ladybugs are able to induce avoidance behaviors in the aphids, which reduce the number of aphids that make contact with a plant. This change in behavior results in lower amounts of the plant being consumed, which allows it to grow healthier. This type of indirect interaction is not the same as the previously mentioned trophic cascade, however. In the trophic cascade, the indirect effect seen was dependent on the density of the species. So, a higher density of ladybugs would lead to a greater reduction in aphid numbers and be more positive for the plant. But with trait-mediated indirect interactions, the effect is present regardless of the species density. As previously seen in the first graph, where the settlement of aphids was similar between all the treatment groups, it was the mere presence of the ladybugs and not their prior quantity which determined the level of the avoidance behavior. Through this project, I've come to understand that ladybugs can play a critical role in controlling pest populations in gardens. Being able to consume large amounts of aphids allows them to lessen the damage caused to plants by reducing the number of pests through predation, and even once they depart from a plant, they can have a positive impact on the plant through their offspring and by reducing aphid activity with their leftover odor. Overall, these interactions allow ladybugs to be an effective regulator of pest populations in gardens and open the door for healthier plants. So the next time your garden gets overrun by pests, I would encourage you to invest in a batch of ladybugs instead of grabbing a pesticide spray.